I presented a talk in Scala Exchange last year, and when I was telling a colleague of mine at the time that I would present a talk about reifications and type safety, and he said, "Well, you really want people to go to your talk? What's that? Like kind of scary name." And so I hope it will not sound that scary later on. So I have the agenda is I will explain my motivation of giving that talk, and then show how this how that problem can be solved using 3 ways: type parameters, type members using type projections, and type members using path-dependent types. One of the things that happened when I gave that talk there is I got someone, a friend of mine, that came to me and said, "Well, I'm not using CQRS, but I learned one nice trick is about how to use type members and why they are useful. So even if you're not interested in CQRS event sourcing, well, it can be a nice way to learn about when you should use type members or not." So how I get into this problem? Well, what is the problem of type safety and reifications in CQRS? Well, the CQRS community says that you should not write a framework. But since I'm stillborn, I wrote it. And it's called Fun CQRS. And it's written in Scala. And then things start to become interesting. Because if it's written in Scala, well, the first target was to use on a project I was working. Well, many different applications we were planning to use, and we were the first users, and but also the community. And since it's Scala, and we like it to be type safe, and but the reifications, as I will explain in a while, introduce a problem for related to type safety. So I need to solve it. So basically, I got into that problem because of you guys, because of the Scala community, because of the way we Scala developers want to code. We want to have as much as we can type-safe system. So, but this talk, I also use that talk to talk a little bit about my journey in building a CQRS framework, solve those problems, but also think about the API that I would like to use when coding CQRS applications. And it's all about finding the right abstraction that I need, putting away all the accidental complexity, and back to what I said about writing or not writing CQRS framework, I don't believe that we should not write it, because the operations of CQRS, they are that simple, and exactly because of that, there are those operations that are simple and easy to grasp, but there are lots of infrastructure around. So if I can isolate those operations, I can build something and leave those blanks, and that's where the user will come and put their code. So when you code your domain, you just have to fill those blanks. All the rest around it, I can offer for free in a framework. So I think it's a good opportunity to write a library or a framework. So that's why I disagree with that. So, and why we do that is to abstract away the complexity to the users, to yourself. And I think that functional programming has some very nice paradigms for that. And if you think about, well, when I talk about infrastructure, I'm talking about I/O and persistency and many other, the dirty word of programming. And functional programming teaches us how to put the side effects on the side, really on the border of your system. And we have many constructs to do that. So why not build a library to do that? And the other thing is, I will explain how it happened. And whenever I give a talk, I learn a lot because I have to rethink things that I have been doing and be able to explain. And in that particular case, when I submitted that talk at Scala Exchange, I didn't have a solution for the path-dependent types. So I showed that there are three ways of doing that. And I didn't have a solution for the third one. And I want to have that solution because I want to move out of type projections because of many reasons that have been announced that it will disappear from Scala. So I want to try path-dependent types. And it happened that at some point I thought, oh, that will be a failure. I'm not being able to find a nice API to do that. I had the solution, but there was some friction that I didn't like. But at the last moment, I found the solution, and I was very happy just before the talk that I had the solution. Say, okay, well, if I couldn't find it, I would give a talk about a failure, which is also okay. But of course, I prefer to give a talk about something that I managed to build. So, okay, so what I mean about reification. So we use the term reification when we talk about types, the type erasure. There is no reified types after at runtime. We can talk about reifications when you have a method and you reify the function. So it becomes, I don't want to use the term entity because it's not the right term for that, but it becomes one thing that you can manipulate that's not a member of another type, but it's something that it's a class. Or in the case of a function, you reify a method to a function, so you get an object, or an instance of that method that you can pass around. That's a kind of reification. So what happens in CQRS is that when you're modeling commands and events, the first thing that you realize is that your model that before in an old way of doing things let's say I have an order, kind of shopping cart application, very simple. And I have an add item, remove items, and remove item, which give me back a new order. That's the old way of doing. So the first reification that we have here is that those methods will become case classes. I will model commands. And I'm modeling one more here that was not present on the previous slides. I have 3 methods, and I end up with 4 commands, because there is one command that is the equivalent of my constructor, the one that will initialize my class, my model. And now my model here has nothing inside. But we don't stop there. There is another reification that is even not here expressed, is how I express changes. And the changes are expressed in terms of events in the past tense. And this is also reification. And the problem that I have now is that I have 3 kinds of objects. I have my model, I have commands, and I have events. And they are unrelated. How can I prove that create order of add item is a command for order? They are just unrelated types. So that's the first problem that I want to solve is I separate my model, I reify my commands, I reify the events. I even cannot say if I reify it because the events were not there, but I create something that is unrelated, not connected to my original model, and now I have to glue them together. So one other thing that will happen is that I need to code my behavior. If you think about, if you see how people have been doing CQRS applications in Java, I have seen some code in blog posts of mailing lists, and people are really creating methods like add item, item added, and on the object itself. Of course, when you do that, that's not abstract enough, because I cannot build a framework unless I start to put annotations on those methods to say, oh, that's a command handler, that's an event handler. I have to teach the framework where are the methods. Unless I do that, or I create some better abstractions. So, and the other thing that we'll see is that people have like something add item, and then it receives an add item command, and it gives me back an order, and it emitted the new version of that order, and the added event, the new event. And of course, we are talking also about event sourcing, so I have to save that event. And what happens in Java world is that people inject in your domain a kind of event store of event publisher, and they publish that event from there inside. Of course, in a Scala world, we don't want to work like that. So, and of course, also in the Java or other language, there are other opportunities, is to just do that outside your model, which is a better thing to do, of course. But it's very repetitive. I'm now, every time that I send something, I have to save my event. And I want to get rid of that as well. So that's the thing about having abstraction, defining the operations, have a clear defined operations, and then cut out some blanks that people can fill. That is one of them. I don't have to save. The framework should do that for me. But I should be able to offer the way, the means to the framework to work, to do that for me. So what I'm looking for is a way to define my commands and events, how to initialize my model, how to define my behavior, because I was talking about the reifications and the commands and the events, but we didn't yet see how can I model my business rules? How can I write it? So, oops, yeah. And I want something that frees my hands from dealing with infrastructure. And of course, and that's very much inspired by previous talk from Bill Venners, where he talked about building an API that is easy to understand and frictionless and only offer what has to be done and nothing else. And so that was one of my motivations as well. So just to illustrate very shortly, because when I show the code later on, I would like you guys to understand why so much code. And then I will have a look on the problem of reification, how can we solve that. But imagine that we have to now to code a domain with commands and events. Obviously, that first code fragment is not that I need. Because if I code like that, I cannot have a library that helps me. What I need are those two other functions here. At some point, I may not have yet a model. I still have to create it. I have a model, I get a command, and I may send back a list of events. In my library, that's not the signature, okay? Because you can choose to return a try, because a command can fail. It can be a future, depending on what you're doing. By the way, the code that I will show is not the code that I have in Fun CQRS. It's very similar, but it's much more simpler that I prepared it just for the presentation. So here, that list, it will be another type, okay? But the event model, it's pretty much the same, the event handler. I may have nothing, and I get my first event that will give me back a sum of my model. Or I may have already a model, I apply an event, and I get a new updated version. And if you look to this signature, it's a very good one to use on a fold left. So when you replay your events, that function can be used on a fold left, having the option M, the option of your model being the seeds and the accumulator of your events. So I want to have something that is type safe, that bring together my aggregate or my model, my command, my events, and where I can declare my commands and events. So let's say that I need this thing called behavior with those two methods. But if I implement that myself, that's extremely annoying to code like that. I have to pattern matching on my option of order and the command. And if I don't have an order, then the command that I receive must be a create order. If I do have an order, or those three, the next three here, then I can only receive one of those commands. And to make the Scala compiler happy, I have to put another case, say, well, and if I do have an order and I receive a create order command, well, that's a legal thing. So in that case, it's a stupid example, but you should return an error. I'm returning an empty list because for demo purpose, I keep it very simple. There's another kind of friction here is, here I am emitting only one event, but I have to wrap it each time on a list because my signature is same. This thing is solved in fun CQRS, but here I decided to make it much simpler. So then what you can do is have a DSL to define your domain. And you see later that this actions thing here, it's something that brings my types that I will glue together later. And it's type safe. I cannot have a command handler that is not handling a command that does not belong to order. And I cannot have an event handler that is not handling an event that does not belong to order. And this DSL will help me to solve the fact that I have here an option. Because at first, I have to create. So at first, I have a none. So I only need to have a function from command to list of events, or a function from events and to model. That's when I'm constructing my domain. The other, once I have something, when I have some model, I don't need to remove the option here. I can have such a function that receives my order, and then I can define what I do as command handlers. Okay, why I'm showing that is because when I show the code, you'll have to understand how all those things are glued together. So I have the reification problem that we'll see how to solve it. There are 3 ways of solving that. We have the need to define our functions, and we want to have that all well typed and as much as we can have like idiomatic Scala code. So the first example that I will show, of course, is the most simple form, which is the type parameter variation. And here I have this order. As you see, it's just a case class. Okay. Here inside I have some actions, which are the actions when I have already order. That's my model. It's there already, and I have the possible actions. But when I don't have yet an action, I have, when I don't have yet my model, I need to create it. So in the companion object, I have to glue that together. That's the first thing. We know how to do that. I want to have now the actions for those 3 types. I glue them together. And then I define my behavior, first create using those actions, and then once you have something, you can update it using those other actions. Okay, that's simple. The thing starts to get interesting later with type parameters. But now I need to tell my framework that I have that order behavior. So who is familiar with Lagon? Yeah, need to have more people, need to promote that more, maybe. Well, it's very similar to what Lagon is doing. And so you define your behavior and you give it, you tell Lagon that exists. Fun CQRS is very similar. It does the same, actually. And at some point, you ask a reference to it. But because I'm using type parameters, I have to, over and over again, tell, okay, give me now an order ref, aggregate ref of order command, and order event. But at that point here, there is nothing to me that will blocks me to do that. That will compile. Of course, this code here is type safe. I'm passing here order command, so it's not compiled anymore. But I would be able to do that because I'm using type parameters. They are not in itself glued together yet. And for some people, that may be silly, but if I'm building an API, I don't want to offer that API because the other part we can argue that, okay, we do that once and that's okay. Like when we did here the, here, that's okay to do that. You do that once, and you don't touch that code anymore. However, every time that I will use my order, I have to pass 3 parameters. So I don't want to do that. That's the most used API when you code like that, because whenever you need an instance, you have to call that code. And I didn't like it, so I need to find another way of doing that. So the other possible way of doing that is using type projections, or type members with type projections. So in that example, I force the user to implement a given trait, which is the aggregate, that has a command and an event type defined inside of them. So that's a way of gluing things together, because now my order type will carry along with him the command and event that it needs. The rest here is pretty much the same. I'm using the same behavior DSL, the same actions, command hands, and that's the same. But when I do my main path projections, then when I do that, now I don't need to pass the command and the event for order anymore, because they live inside the order. So by doing that, I believe I am offering much better API now. So I just say, I have an order, and go there, and you find the other types there inside. But what happens here is that there inside on that method, so disregard this one here because it's just for demo purpose and it's not so much important. But there inside, I have to navigate to my other types, so the command and the event. And I do that by using type projections. And that's the first reason why you'd use type members. Is not because it's fancy, it's because there are some types that belong together, so you can define them inside another one, and as such, you don't have to declare them over and over again. The main type carries on the other ones. And there are ways of navigate to that, and the first one is the type projection. And the thing is, well, I don't even understand the real reasons why they are removing type projections. They say that they are not sound. I don't have enough computer science background or programming compiler knowledge to understand what the reasons for that. But what I have experienced in CQRS while doing that is that in some situations the type inferrer would not work in the way I want. And it was painful, and I was also the CQRS API is much more, well, the API is very similar to what I'm showing here, but the things that happens behind are much more complex than this demo thing. And the type project was beating me from time to time. Like I say, I did something, I say, why that's not recognize the right type here? And well, and I solved that by trying until that compiles. I don't know if that's the same for you guys, but when I do this kind of stuff, it's not that I can see if wow, I know why it's not compiled. No, I don't know. I will try and say, okay, I find how I can encode that. I could drop a mail to Miles and ask some assistance, but I don't think he's selling subscription for that. So anyway, by the way, the solution I have for type projections was after talking with Miles about that problem. And he gave me a very simple, clever solution, is why don't you put those types inside an object? I said, well, obvious. And so I went for that, for the next one. And it changed a lot, the API and other things that I can do. So first, my order here is not implement whatever, okay? It's just an order. However, I can, oh, it's not this one. It's this one. Okay, again, my order here is not implement whatever, because the types will not be defined inside a class, but they will be defined inside my other companion object. I still have to let my companion object implement something. I call it types. Maybe not the best name for that word, name for this trait, but it's where I will glue them together. It's like the aggregate on the previous one, but now it's something that I targeting. The goal here is to use that implement it by the companion object. Then, what happens next is that there inside, I will remove this one. Don't want you guys to see what it was, because that's the interesting part for later. Well, inside that types, I can let you define the command and the event. And I can also now, because it's there in the companion object of in this object that we implement types, now I can also define that actions for you. So you define the 2 type members that you have to define, and you can already access the actions there. Don't read. And now I can use the actions to build my command handlers and event handlers. And the types are all there for me. And again, here on my class, I can access via my companion objects the actions. So it's a better API, I believe. And what's next is that path-dependent types. Here it's exactly the same as the type projection version, exactly the same code, but this backend here, this backend has another implementation from this aggregate ref. And this one is using the types. So it's requiring, and that's what I was not happy with. I said, okay, I put those types inside an object. How much time I do have? Hello? I don't know. 20 minutes. Ah, that's great. I talk a lot. So when I was looking into that solution, okay, now I can have this object that carry on my types, but I had 2 options. Whether I put, when you ask for an aggregate, you have to give me the types as an explicit argument, or I put it as implicit. And the thing is, and that's why I was not happy, because as I said, I want to offer an API that is as much as possible, frictionless as much as possible. So if I have to remind people, oh, don't forget to give me that object as well, because I need to know the types, or don't forget to put the types in an implicit scope, then I think it's not a good API. Yes, Tomer, say. Yeah, I will repeat the question.
So 2 questions. One, why did you split, like the behavior has basically 3 type parameters. One is the model, one is the commands, one is the events.
Yeah.
Why did you make the model a type parameter and the rest abstract type members, and not all 3 as members?
Well, okay. So the question is why I have why I don't have all of them as type members in my behavior, but I start with one type, the aggregate, my model, with the other types inside. Well, if you look how that was achieved in Lagom, is that they have this entity that I have to code, and inside the entity you put 3 things: the state, which is the equivalent of your model, the command and event. It's one solution. So you create a type and have everything inside, and you keep using that. The reason is that when I was building that, I just found that was more, I didn't thought about that solution actually, to create a kind of entity and let people define the type members inside. I did like, well, that's my model, and I need to bring back the commands and events inside it somehow. That's just the path that I took, and actually that's basically historical. But I do like this because at the end, I don't need to have another kind of concept. It's just I have an order, the commands, and the events that goes to the order with the others. What I need to have is the types that I have to implement to glue them together. You said I had another question? Or? Okay. So the thing now is that I have these types in my companion object, and from the API point of view, I have to ask users to, well, don't forget to put it in scope, because to offer that same kind of look and feel, let's say, I don't want you to say, okay, now give me the order here. Give me the types. I don't like it. So I want people to use the API without having to think about that. But I also don't want to force you to put something in the implicit scope. And the thing is, just to explain what the path-dependent types does before I go to the trick that solves that problem of the implicit scope, is that now I'm accessing the commands and events, but using the instance of my types. And that's the difference by path-dependent types, because type projects, you go from one type and you navigate to another one, and path-dependent types, you go from one value, something that you have a value, and you go to a type. So it's like a bridge between value-level programming to type-level programming. You go from value to type. And so you need to have an instance. And in our case here, that's not something that I need to initialize when I need. I just put it on the companion object, and it's a singleton, and it will always be there. So I navigate from my companion object to the types, from the instance to the types. That's what we do here. And then I get everything well typed. Now, how I solve the fact that I need something on my implicit scope, and I was very happy to, was that little trick here. You can define in a trait a method, a def, that puts itself in the implicit scope. And the fact that we are putting that on you don't have to put it on your companion object, but it's the best place to put it. Because when I have to resolve, when the compiler will try to resolve the implicit scope, the scope for that implicit, it will first look on I don't know if it will be the first place, but it will look on the companion object of the type that we are giving. So it will find it there. And there are two tricks. In the beginning, it was not working. The first one I knew, and well, I didn't make that mistake, but if I got someone ask me why you did a dev, not a val. It's because if I do a val here, and because it's returning itself, I have initialization errors. It will slam you in the face. The other one is that one here. Whoops. We need to, if I say that's the one that I put in the implicit scope, that won't work. So, types, okay. That won't work. So what we need is to put the type that I don't know yet, but will be the type once that trait is implemented. So it's this type that I have to put on the implicit scope. And that little trick, and I hope that it's not one of those unknown feature in Scala that one day they say, whoa, that should not happen because of that, and they remove it. So, but now it's registered in a conference, so they cannot remove it, okay? Even if it's only on my library. But I don't think it's like that. But I was surprised. I was really happy. I said, wow, I got the solution, because now I can go for path-dependent types, and as long as you implement types in your companion object, you get that implicit for free. And there we go, we got it. And just to give more or less the idea of how it looks like at the end is, so I glue my types using the types, using path-dependent types. I bring them together when I define my behavior, and I try to have DSL kind of stuff that is very clear. First, I create using those actions, and then I update. And very much like in Akka, any resemblance with Akka is mere coincidence, okay? I can send commands to it. Well, why it's like that? Why it looks like Akka? Well, because my first implementation was Akka. When we started doing CQRS, I was working at the Flemish government in Belgium, and the first thing that we had in mind was, we don't want to code our aggregates inside as an actor. We found that was the too powerful abstraction for what we were doing. And we said, if we define the functions that we need, then we can have something that we can encode, and say, now I take that and I make it work inside an actor if I want, because the semantics are very similar, send message, they are persisted using Akka persisted, and I get back if I want, if I do a ask, I get back the events. So that's why it's so similar. And yes, Tomer?
Sorry, circling back to the type API, types API, because you have everything as part of the types trait, and you're prescribing that an aggregates companion should implement that anyway.
Yeah.
Why take in a type parameter and not just take in the companion and avoid the whole implicit thing? Like you can take in the order companion that implements types.
Yeah.
Just have the same kind of
Here. Wait. You mean here?
Yes.
Like that? Yeah. I tried that. And I didn't like that solution because I think it's not natural if I ask a reference of something for a given type to pass an instance of something. I think from more the perspective of the language, the Scala language, have something where I give a type, I express this as a type. I want a reference for order, the type order. That's more a style thing. I try it, and I thought, I don't want parentheses, I want brackets, because now I'm telling, give me a reference for this type. That's the reason. And so it's very similar to Akka because my goal was to build that abstraction so I could put it inside Akka. And, but the outcome of that and many other things that I have been doing from CQRS and make sure that I have this frictionless API was that I could abstract away the idea of a backend. And the Akka backend, I have two backends, the Akka backend and the InMemory backend for testing, but you could implement others backends. Who was on the Lutz talk about CQRS? Yeah, okay, lots of guys. Thank Lutz for the advertisement because lots of people here are coming from your talk. So he mentioned eventuate. And actually, I never tried, but I'm pretty much sure that you could build an eventuate backend for CQRS. And I had plans to build a slick backend for CQRS, but then I quit that project at the Flemish government, something that they will build there probably because they need it. And the nice thing about that is that the InMemory backend, I take the same behavior and say, now I just want to test my commands, command handlers and event handlers. But the complication there is that when you do that, what is the return type? If I do here ask, what is the return type of my, here is not working because it's simple application, okay? But in CQRS, what will happen is, if I got that ref from my Akka backend, the return time will be a future. But if it's from my InMemory backend, it doesn't make any sense to have a future. I don't want to force myself to deal with future for something that I'm testing, running pure unit tests. So I have some mechanism that will, using interpreters, and will, instead of give me a future, will give me just the events. But the thing is, and that's why I believe we should write frameworks for CQRS and event sourcing, is because the set of operations are well defined. And if you have that, and think about Akka HTTP and Akka streams, they are based on top, they are built on top of Akka, but because the set of operations are well defined, well, maybe not the streams are still to be well defined, but HTTP is well defined. So you can build an abstraction that is less powerful on top of Akka, and then you offer an API to your users and to yourself that only allow you to do what you are meant to do. So I have another talk. So to wrap up, so in FunCQRS is available on GitHub. So if you take that talk and you want to understand how it was built, you can have a look and use it. The talk and slides are on Reifications in CQRS. On my strong typed is the name of my company. I will be talking Scala Swarm in Porto about the functional foundations of event-sourced applications, which are actually the basis of FunCQRS. And I recently blogged about that. So I started a series of blog posts. Don't expect to have one a week. I'm much slower than that in writing blogs. But the first one is about the functional foundations of CQRS. And also in Scala Swarm, we are running a FunCQRS workshop. It's only one day, and it's very affordable. It's 99 euros. And well, if you have a colleague that couldn't make Scala Days, or if after Scala Days you're still in Hungary for a nice conference, I really recommend Scala Swarm, not because I'm speaking there, because I know the guy that is organized that, and I'm sure it will be a wonderful conference. So I think I'm done. If you have questions, if you have time, 5 minutes, perfect, like I planned it. Any questions? No questions? Tomer?
Can you implement the state pattern, like context count in Akka?
Hello?
Yeah, okay. The question was, can I have something in FunCQRS where I can change my behavior to go from one state to another? Yes, I can. And actually, it's not done here, but I'll just show here back. That function here is a partial function. And what I have done in other demos is that my model is an ADT. I have a demo. It's a funny one that I use many times already. It's a raffle. So you start with a raffle, and it's an empty raffle. As soon as you put a participant, it becomes a non-empty raffle. And you add participants, and when you select a winner, it becomes a finished raffle. And a finished raffle cannot accept comments anymore. You cannot remove a participant. You cannot run it again and select another winner. So what happens is, and on that piece here, you say, okay, if it's order, let's say that we have something like, if it's order empty order, I can do the actions like add an item and so on. If it's that, an order pay it, something like that, then I can not add items, I cannot cancel because it's end of life. So that part here will allow you to, oh, I didn't, sorry, it's not, but I think you guys got the, it disturbs me if it's not compiled. I cannot continue talking if it's red. Yeah, like, you know, you guys are developers, no? You understand that, no? So what you pass here, and that's a very much simpler example, but it's a partial function. So you can switch from behavior, because the actions are actually what will be used in the receive method of your actor, or to whatever backend you have. Yeah, so that's how it's done. Any other question?
Yeah, over here on the right.
Okay.
So I noticed you have a one-to-one relationship between command and events. Is there a reason for that? Because one command could potentially generate 5 events, and 5 commands could generate 1 event if you're tracking something over time. Yeah, I tried that. So before reaching that API, I tried many others. If you go to the GitHub in FunCQRS, you see all these experimentation ideas. And one that I have done is, once you add a command, and I say that command gives me back that event, you had to declare an event handler for that. So I was trying to force you
if you tell me that you emit that event, you have to teach me how to handle that. And of course, there are situations where two different commands may emit the same event. And that's why I give up from that idea. Because then you create a command handler and say, I will send you item added. So I force you to put an event handler for that. And then you give me another kind of command that will also emit that event. And it happens depending on your model. And now I have to force you again to implement the event handler. I said that's not a good API. So, but to answer your question, yes, a command, a given event can be emitted by different commands. And a command can emit more than one event. And one of those events can be emitted by, if you have a list of events, for instance, I don't have that here, but imagine if I create here a command handler that does that. But he is on the creation part of it. Oops. It's possible at creation time to send a command that is creating your library, your model for the first time. But what I have to do here is I have to emit a list of events. Oops. My first event has to be create, and the other one, item was added. And the thing is, the API, all those things, when you start, you think, oh no, that will never happen. And I did like that. It was impossible to do such a thing in the beginning. But then, as soon as you start to develop many applications, say, wow, now I need that. So I was changing my API to be able to provide that. Does it answer your question? Yeah. Okay. Thank you. Another question? There's a...
Hi, thanks for the talk. I was wondering how you handle transitions between states, or like the sequence of valid events. I'm thinking, because you have partial functions, like how do you know that someone doesn't try to apply an event where you can't?
Yeah, well, the backend will take care of that. What it does is, okay, you send a command, you give me a command hand that will emit an event. I think we are finished. No? Okay, I will answer this, and maybe it's the last one. So what I have done is, because I control the state in my backend, what I do is I apply a command, I take your events, and I try to apply the events already before I persist. And if I cannot find an event handler for it, then I will reject your event before your command before I persist your events. And then you get at runtime the notification that, well, that didn't happen because I cannot apply those events. So I avoid you to persist events that you cannot handle, because if you do that, you break your actor completely.
So have you considered doing this on the type level instead?
No, I didn't. I thought I thought about that, but I got the feeling that I would add a lot of API and friction and lots of things that have to achieve to add up in order to do that. And I thought that I didn't want to do that. I thought it was a case that it was okay to have, in that case, runtime errors. And the thing is, also, if you send a command that you forgot to add the command handler for it, or let's say I show that you can do a state machine and go to a state that maybe cannot handle that command, I have the means to detect that and say, oh, that command for that current state is not possible. But it should be possible to do that at type level, but I thought it was not something that would be that useful for CQRS.
Okay, thank you.
I'm open for experiments and pull requests. Guys, I think we have to thank you.